So probably around 7000 BC is when you started seeing copper being melted. Copper doesn't melt real easily. It's not that fluid. It's kind of sluggish. And in the old days, one of the biggest problems was temperature. How do you get the temperature up high enough, 1800 degrees, so you can melt something? So it's not that easy in the old days. And then somewhere around 3000 BC, Hittites, which is up in northern Turkey, started developing casting. And they started with a simple open-face mold, and they pour copper into it, so they could have on the inside, that down part of the mold, they could put like decoration or anything they wanted. So one side would have decoration and the other side would be flat, okay, because of open mold. So then they came up with, obviously somebody came up, why don't we put two together? And then we can have decoration on both sides. And this was in sandstone. And so that's how it all started. And then obviously it filtrated into other places, Mesopotamia, but the Hittites were the first. And so then it filtered down into Mesopotamia, Egypt, about 2700 Egypt got it. They probably were the most sophisticated with it. And they started using the investment because they knew about plaster. They were using plaster already, so they started doing that. And then it just developed from there all over Asia, every place. Although China may be even older than the Middle East. They see things that are bronzes and they're saying they're 5,000 years old, but nobody knows that for sure. Then South America developed all of their casting by themselves. They had no help. In the other ones, you have the knowledge filtering down through all these different places, but South America, nothing. They developed everything by themselves. By 300 BC, they were casting copper. And what happened with how bronze came about was sometimes with copper there's tin, okay, the ore. And so when they were melting the copper, the tin got in there and they went, oh, this is more fluid, it's more flexible, elasticity was better, and also it was shiny. Because what they did a lot besides weapons and some plows and things like that was mirrors. So everybody was into mirrors, so they would polish up the bronze with tin in it. Tin makes it very shiny. And the Chinese did a lot of that. They would use, normally at what you call tin bronze, 10% tin, 90% copper. Chinese went up to 40% tin. So their mirrors were really reflective. Well, you could really see your face in those. So anyway, that's how it all started, and it migrated all over the world, and so you're doing something that's very, very old. One of the problems we had when I started working at my foundry, Quest, was nobody had ever told me the kind of the principles of everything. We knew it worked, we knew how to do it, we knew that we could get something if we did this and this, but nobody said how it worked. So my partner and I developed how it worked. That's how I did my first book. We'd find out what was directional solidification, what a vortex was, all these different things that are related to how you can cast metal. And so because when I went to school, it was kind of a mystery. It's kind of like magic, this is what you do and this is how it works. Great, But in the foundry, we were trying to make money, and we couldn't have it mystical. We needed to know scientifically how this worked, so we could fix everything. So anyway, okay, let's go on to safety. So most of this stuff here, we're going to be using cold or semi-cold. Okay, there's two ways to do patinas. Okay, so patinas are an oxide that forms on metal. On non-ferrous metal, it's a protective coating. Non-ferrous is copper, brass, and bronze, and all alloys related to it, okay? And then you have ferrous metals, which is iron or steel. Iron is actually stronger than steel in resistance. It's not stronger in tensile strength. Steel is much better. But, so you have these two different ones, and you have two processes that you can use on either one of them. That would be a hot patina. That means the metal's hot, and the patina goes on the hot metal and activates instantly. You get instant results, okay? Cold patinas, which is what we're going to be doing mainly today, I'm going to warm them up with a heat gun, but it still won't get the temperature I need for a hot patina. Hot patina is around 220 degrees. So we're going to do basically everything cold and semi-hot, okay? So cold patinas takes a lot longer to activate on the metal. That means instead of taking 3 minutes or a minute and a half or 5 minutes to get your color, it may take an hour. And to actually bond to the metal takes about 2 weeks to really bite in and bond to it, to have the same strength of the patina as a hot patina. Because when you heat up metal, you open the pores. So when you shoot the patina on and the metal cools down, it locks in the patina. So it's very strong, very quickly. Cold or much more fragile, okay? But we have all kinds of different patinas here. We have acid patinas, which means the acid is actually starting to affect the metal, starting to attack it, actually, but it leaves a protective coating called an oxide, okay? So when you see a green patina on copper, that's an oxide. That's formed because the copper is going, oh, I need to protect myself, or bronze, or brass. Iron and steel is trying to do the same thing. The problem is it doesn't do it. It's actually eating the metal, okay? But iron is at a slower rate than steel. So iron, you see iron pieces 1,500 years old, still around. You would never see steel that long. It would never last that long. It would start to break down so much quicker, okay? So we have two kinds of patinas. We have hot, where you heat the metal, put the patina on, and it activates. And cold, where you put it on and it goes much slower. Now there's also, besides acids, we have non-acid patinas, which again are oxides, but the oxides have already formed, greens, browns, reds, oranges, and we're putting those on there and they're laying on the surface. Some have a binder, so we bind it to the metal. Some don't have a very good binder, so you have to put a protective coating over it after you're finished. So we have a lot of different possibilities. We also have lacquers with color in them, so you can tint your patina if you want. We have Smart Stain, which is a water-based, a water-based coating that you put on. It again has patinas or colors in it, and so you can put all kinds of colors on that way. So we have a lot of different ways to go depending on what you're working on. Later on today, I'm going to do ceramics. We have coatings that put metal on ceramics, and so you can do the same thing as I'm going to do here today. With these, you can do them on anything you want. Cardboard, you can do them on steel, you can do them on clay, you can do them on anything you want. It'll look just like a real piece of bronze or a real piece of copper or a real piece of brass. Okay, so we'll do that later on today. Okay, so all of these are good for sculptors as well as jewelers. So jewelers are real good with our products. Ceramicists use them too with our coating. I do ceramics too. I taught ceramics. I've taught everything except jewelry and printmaking. At the academy, I taught life modeling, drawing, painting, and I taught one other, basic sculpture. I taught 4 classes when I was here. Okay, here we go. So you have what you call base patinas, what I call base patinas. Could call them very traditional patinas. And what they do is they turn the metal. This could be iron, steel, bronze, brass, or copper, generally either a brown or a black, and that's called your base patina. That could be your total patina, or it could be the starting point for something else. What happens when you put something on that turns it brown or black, and you burnish off the top, you get the dark in the recesses, okay? Now, let's just go into one thing over on the board here. If you don't have good metal preparation, then the thing is not going to stick. Sandblasting is the best way to go. It's sort of like pixels on a TV. The more pixels you have, the better the picture, the more clarity you have. Well, the more little indentations you have in metal, so metal would be normally like this, okay? Not a lot of little grooves for the patina to go into, and when you're doing a cold patina, you want as many grooves as possible, so if you have sandblasting, it looks like this, generally. This is microscopic, but that's what it would look like. So you have lots of little valleys for the patina to go into. So sandblasting is absolute best. Next thing would be sanding. So sanding would be generally something like that, but not as good as sandblasting. Besides that, when you're sanding, you can't get in all the little nooks and crannies very easily if you got a piece of sculpture. You know, if it's a flat surface, great. You can just go with an orbital sander and maybe 100 grit. On sandblasting, I usually go 100 grit or 100, between 40 and 100, depending on what I'm going to do. If I was going to do a hot patina and it was going to be transparent, then I would use sand that was 120, or I'd use glass beads. Glass beads look like this on the surface. So a lot of places will use glass beads. I like sand. I use sand all the time, hot or cold. Okay, so, but glass beads, a lot of people like glass beads. It's a little softer, a little more gentle, a little different look of the metal when it's finished. But the best would be sandblasting, you know, especially if you got a flat surface. Orbital sander is great, you know, sheet of steel, sheet of copper, a little piece of copper, fine. But if you've got something with lots of nooks and crannies, whether it be the figure or abstract sculpture, then sandblasting is the way you want to go. So metal preparation is really important. Also, generally what I do when I'm going to sandblast, copper generally doesn't have a protective coating on it. Bronze doesn't have a protective coating on it, so you're fine there. But what I usually do is I will take acid, and this is a cleaning acid, metal cleaner it's called. You can buy it. Douglas and Sturgis has it. They have all this stuff. And usually I'll clean the metal first. First thing is to clean the metal. And so if there's any grease or anything there, it gets it off. Okay. Then second, I sandblast. Then third, I go back to the metal cleaner again. Okay. And I might use naphtha. A lot of times if I'm doing a hot patina, I'll clean it off at the very end with naphtha. Okay. It's a solvent. It's like, you know, lacquer thinner or something like that. It's a solvent, and it works really nice too. So those are the things that are really important. So particularly for cold patinas, because it's hard for it to bond to the metal. You want to give it every chance you can get for it to bond properly. Okay. Anybody have any question? Most of these here aren't hazardous, mainly because we're doing them cold, so all you're getting cold is just a tiny bit of vapor. Now when you're doing a hot patina, you got lots of vapor, because as that patina is hitting the metal surface, it goes and it steams off. Well, that steam has got stuff in it, so you don't want to breathe that in. So you have choices. One would be to have a mask, a vapor mask. You can buy them. They're not that expensive anymore. If you were doing a cold patina and you were rubbing off some of it, you would want a charcoal filter mask, okay? Because you're getting that little airborne dust. And that dust sometimes, depending, I'm allergic to a couple of them. If I don't have my mask on, I start choking, going, you know. So you want to wear a mask, you want to wear gloves, you want to have an apron. Those are really important. Gloves are really important, as well as, you know, protecting your body from any of the fumes that are going on or of the dust. So you want to wear a mask. But most of this stuff here is not going to do much to you. Okay, so the first patina I'm going to use, this is Birchwood Casey, the oldest patina company in the United States. They did gun bluing in the beginning, probably 1890s, okay. They make 4 patinas. They make a brown, they make a black for copper, brass, and bronze. They make a black for steel and a black for aluminum. We haven't talked about aluminum, but we can patina aluminum too, just like a bronze. It's very easy to patina aluminum. So aluminum is a possibility. So these are Birchwood Casey. This is M24. It's their black. We have M38, which is their brown. I also have a bunch of ours. I have darkening. We have our own that we developed. This one here is called Black Magic. It works on everything. Works on copper, brass, bronze, iron, steel, aluminum. Okay, it's kind of an overall one. And then we have different things. But we'll start with this one here so you can see. So this is not really done well sandblast-wise. See all those little things? That's oxide that's formed on the metal. And this has probably been patinaed 20 times, you know. Every time you patina hot, you're going to get a little bit of the acid left in there because you open up the pores and you close them. So when you sandblast, you're getting that top surface. So there might be a little bit, so your patina might not be exactly what you think it's going to be, but it's fresh metal like you guys have your castings. Anything you do is going to be good. Virgin metal is the best, obviously. The more times you patina it, the more things that go on the surface in relationship to what's going into the pores of the metal. Okay, so where are we here? This is the most traditional. You guys, if you haven't used this, you will be using it all the time. Liver of sulfur. It's the oldest one there is, sometime in the 1800s. Hot patinas, even mostly coal patinas, didn't come in till the 1800s, late 1800s. Before that, they did faux finishes, where they took varnish and put pigment in the varnish and put them on their bronzes. And what they were trying to do was duplicate the Roman and the Greek sculptures that they found in the ground. Well, you can bury things in the ground and get a great patina. I do what you call buried patina. In my book over there, you can see it. I have a whole chapter on buried patinas. I do mostly buried myself for my work. I want it to look 1,000 years old. So they were looking at these and going, how did they do them? And they really couldn't figure it out. They did not figure it out until the middle of the 18th century. Then you started seeing patinas. And then with Rodin was one of the first to do hot patinas. He didn't do them. They were the Lynette brothers, two people that did them for him. But that's when they started doing hot patinas. Before that, they did cold. And they were having a lot of trouble with coal because it doesn't bond like hot patinas, because it takes time for it to bond to the metal surface. So they're going, this is chalky. I don't like this. So then you'd have to seal it. So that's when sealers came in. The first was beeswax. Everybody started using beeswax. In the ancient times, everything was shiny. They weren't looking for patinas. They were looking, bronze was. In Egypt, during the time of the pyramids, they were using bronze or copper chisels. They would take the chisels away from the workers every single night because the copper and bronze was worth more than gold. Copper and bronze at that time were like, whoa, man, if you have a piece of copper or bronze, that was something, okay? Much more than gold or silver. So, okay. So, liver of sulfur. I have 3 different strengths here. It's going to say medium, light, or heavy. And liver of sulfur comes in chunks. It's going to be your basic patina that you're going to use more than anything else. This is what it looks like. If it's kind of darker than this, now liver has changed in its look. So it's darker than it used to be. If it gets too dark, throw it away. It's no good. Liver generally lasts about 2 days. If you put it in alcohol, isopropyl, rather than water, you'll get a week. Okay, because there's a solvent in there along with water, so it lasts longer. But generally only about 2 days or 3 days. You guys are going to have to throw this out, make new, fresh. You should always use distilled water. The reason for that is water have different chemicals, and they have calcium, and they have chlorides, and all kinds of stuff in them. So that's going to basically, on a lot of things, change your patina. It depends on how accurate you want to be in the colors. Lou wants absolute colors in his. If you look at his, it's in the book there. Some people don't care. So if you don't care, that's fine. Okay, so you're going to see this forming very quickly. You start to see it forming, okay? This is a medium. Now, if I put the dark on, wherever the dark is, here. This is strong. Let me show you what strong will do. That's what medium will do, so in 5 minutes that'll be browner. Okay, watch what happens when I put the... We're leaving all this stuff for you. This is all for you guys to do what you want with. You'll see how much faster this goes. Now, there's a good part to that and a bad. You might not want it to go too dark. That's up to you. But we're going to take this off anyway. It's not going to be like this. This is just a starting point. So you can see how much stronger the strong is as opposed to the light or weak. That's what I put on there. Okay, so then the next thing, a lot of patinas, not all of them, we'll talk about ones that you want to neutralize and ones you don't want to neutralize, okay? So this is called a Scotchbrite. This is what you generally, liver smells stinky. I have a story here at the Academy. Another one is ammonium sulphide. That's stronger than liver. So my grad assistant at the Academy on Sutter Street, that building there, he wanted to do a piece using ammonium sulphide. So I had a gallon container. I gave it to him. So I'm at home working on my sculpture, looking at the TV, And I go, we're going to have to evacuate this building. There's this incredible thing going on inside. It's smelling up the whole building and everybody's leaving. I went, oh, that looks like my building. So what happened was my assistant, he was a character, had dropped the gallon container of ammonium sulphide in the basement. It went right up the shaft of the elevator and permeated every single room. That nobody could go in for 3 days. I'll give you even a better one than that. So I'm taking ammonium sulphide to, I was doing a seminar in Canada. So I take the plane out of Princeton, get it to the airport, Newark, go in and had a drink. I drank then, and got on the plane. So I had put the ammonium sulphide in a special container, big, thick plastic, in a box. So they had put it on the plane. So I'm sitting there, we're getting ready to take off, we're down the runway, and all of a sudden this lady comes on, stewardess, and she goes, is there a Mr. Seward Johnson? That was my boss. And I went, well, Seward's not here. And then they said, is there a Ron Young? And I went, yeah. Everybody, they said, well, could you come to the front? And this was on a Boeing 747. So I came to the front, and everybody's looking at me like I was a terrorist. There weren't that many terrorists back in that point, but that's what they were going. Why is this guy? They stopped the plane. They brought up one of those ramps, you know, those ladder ramps, opened the door. I got out. There was 4 FBI agents on the ground there, came down. They handcuffed me, took me into this room. They said, oh, and then they had the bomb squad with all their stuff on, and they had gone into where all the luggage was and everything, and they had this little thing, and they brought out my box, and they put it down, and they took me in this room, started interrogating me, and they said, what's in that box? And I said, nothing really bad, ammonium sulphide. And they went, ammonium sulphide. So they brought it up on their computer, and they found it was nothing. But they stripped me down completely. They kept me in there for 45 minutes, and then they let me come back onto the plane. Not the ammonium sulphide, by the way. That box went. Okay, so that's liver of sulfur. Okay, it can be darker, lighter. If you're going to do a hot patina, I always tell everybody, make sure you get all of the dark off, because when you heat it up, it's going to have some dark going back into it. Cold patina, this is fine the way it is. Now, if you see I put it into water, that's to neutralize the chemicals. All of your base patinas, and I'm going to show you a couple, you need to neutralize them. So these are Scotchbrites. This is gray, what I usually use. This is green, a little more abrasive, sort of like sandpaper. Okay, this is a more abrasive one. Red is more abrasive than the green, and then you have white, which is useless. This is probably, if you were talking about steel wool, 4/0 steel wool, it's useless. I never even use it. So now this gives me nice tones, and what we're going to do, hopefully, with you guys throughout the day, we're going to work on your bronzes. So I'm going to help you with your bronzes. But I'll kind of give you an idea of what we're going to be doing. Okay, so here's one, liver of sulfur. If it has streaks like I've got right there, you keep working on it. If it's a hot patina, which you guys will do eventually, you might heat it up, look at the darks and lights. Maybe it's too dark, go back, Scotchbrite it again, heat it up again, and go, that's what I want to start with. Okay, because it's your starting point. Anybody have any questions? It's a lot of information, you know. I used to do 2-day seminars. By the second day, everybody was glassy. You know, they go, you know, they couldn't take any more information. It's too much. Too many streaks. You don't want streaks, because those streaks, if you're doing a transparent patina, are going to show up. Now, if you're doing a cold patina, doesn't usually matter, because all the patinas we have that are cold are generally opaque. Opaque green, opaque blue. Okay, so it's not as important on this base coat, if you want a base coat. Here, you can pass this around. I got a streak on it, but that'll have to be, it won't hurt you. I mean, there's nothing on there. Okay, we're going to try one of Birchwood Casey's. We're going to try their black. and that's M24. So if you guys want a black, M24 is your thing. Now, you're never going to get a jet black in the beginning. You're going to have to put the patina on 3 times to get a jet black. So let me show you what it looks like the first time. Hopefully it won't make me a liar. M24 is more stable than liver of sulfur. Liver of sulfur and another one I'm going to show you, over time will get darker. I don't care what you do to it, it'll sort of darken. If you have a soft brown on there, kind of that transparent gold brown you see a lot in sculpture, over a 5-year period it'll become more of a chocolate brown if you have liver on there. Okay, so there's M24. Okay, now that's kind of a brown color. So what we're going to do is we're going to put it on again. So there's the first shot of liver, of M24. Okay, nice brown. Yes. Yes. All of the ones I'm going to show you, I'm neutralizing. Absolutely. If you didn't, you get this kind of a milky white coming up on the patina after a little bit, which you don't want. Okay, so we'll do it a second time. You'll see it'll get a lot darker. So that's the second time. Okay, we'll do one more. Obviously you'd want fresh running water, not a bucket, because you're contaminating the bucket. In a short period of time the bucket's going to be contaminated. I will. Okay, there's 2. Okay. I'm going to just give you most of the basics today because it's too much if I give you, it's just too much information. YouTube, they say people can't grasp more than 5 minutes worth of lecturing. Okay. That's YouTube, so. Okay, there's 3. Okay. So, if I go 4, it'll even be darker. Okay. Okay, we'll do this. This is black magic, so you guys will see it. Remember I told you black magic will work on everything. It'll give you a dark on aluminum, give you a dark on steel, iron, bronze, brass, copper. It's my most universal patina for darkening. Okay. It's very strong. The nice thing about it in relationship to steel, which is what I made it for, one of the problems with steel is when you put a patina on it, if it's got an acid, it doesn't take very long before it goes to rust. Doesn't care. I don't care what the acid is, what the patina, if it's got acid in it, it's going to go to rust. So this keeps it from rusting longer. Instead of having 10, 15 minutes on steel or iron, you might have 4 or 5 hours before you put another patina on, or you're going to seal it, whatever you're going to do. Now the orangey color has nothing to do with rust. It's just it's what I have in there to make it not rust on steel and iron. Okay, so that's, you'll see it's a different looking black than this black. All of them are going to be a little bit different. Okay, can you see that? Just a little bit different. This is more of a blue black. This is more of a brown black. Okay, liver is a brown black if you want to take it there. You can take liver there too by heating up the metal after you put on the liver. And if you see a spot, you put a patina on and there's a spot that's not taking the patina, that means you haven't cleaned it well. There's grease, there's oil, there's something there. Okay, so we'll pass these around. And then we'll work on top of these. What I'm going to do is work on top of them, but this will, remember this is black magic. This is M24. Okay, so those are basically your blacks. Okay, now if you're wanting the patina to be more transparent, more softer, brighter, you don't want to put a black base on it. When you put a black base, that makes the patina more somber. Okay, so if you want a more soft look, more vibrant, then you don't want to put any of those on there, because it's sort of like a canvas. If you have a white canvas and you're putting paint on, light goes through the pigment and bounces off the white and comes back and it illuminates. Okay, that's called luminescence. That's what they did in the 16th century. It's called layering. It's called luminescence. I used to teach that. I probably was the only one that taught that. I like it. Anyway, so if you have a black surface, when the light goes through the patina, it sucks right into the black. Okay, does that make sense? So if you've got a shinier surface, bronze, brass, copper, you're going to get a more reflective color than if it's black. Okay. Oh, to be a good patina guy is called a master patineur. That takes 10 years. That's what the French think. 10 years, about 10,000 hours. And I used to tell my students, very many of them listened to me, but I told them anyway, if you learn this, learn what you can from me, go to a foundry, work in a foundry. If you can do all the patinas day in, day out, it's practice. It's a craft. It's a craft. Okay, then you get better. And it depends on what you're looking for. If you want a lot of control, like Lou has in his pieces, some of the other people in my new book, then you have to work at it for a long period of time. If you're looking for random color, not a problem. Just put it on. Okay, so about 10 years. And I told my students that if you do this, go to a foundry, work at a foundry, you can make $110 an hour. So all my students that actually did that, which were about 4, at least in the last, when I stopped teaching 11 years ago. So I'm an old retired guy. So, and they make all the ones that I taught this, they're making over $100 an hour, and they're booked up for a year to 2 years. But they both did what I told them. They went to a foundry, worked in the foundry, did the patinas, or for an artist or something like that. And over time, you get better and better, and you learn all the problems, and you learn what makes it work. Okay. Make sense? Okay. So, next one. These are the two you guys will probably be using the most. And that's light green. It's kind of a pea green or an apple green. Goes real quick. Tiffany Green is from Tiffany's lamps. This is Tiffany's formula, but I tweaked it a little bit, make it a little bit, I think, better. But that was always a secret. And the formula that we got, everybody got, it's that formula, didn't work like Tiffany's. And nobody knew why, myself included. And I used to work for 2 galleries on Fifth Avenue, Lillian Nassau and Macklow. I restored Tiffany lamps. That's another great field to be in, restoration. But it all relates to patinas, so you learn all this stuff. So anyway, but I didn't know how they did it, and I never was able to duplicate their patina. I had to faux finish. I had to use paint to make it look like the Tiffany, okay? I only learned how to do it about 14 years ago, and I learned the secret. Formula is fine. Everybody thought, well, he left out something. It's not all in there. It is. It has nothing to do, it has to do strictly with application, how you do it. And that's what his secret was. Because workers used to dip them. Workers would take those lamps and dip them in the patina and put them on a shelf, walk away. Okay? And you go, well, if they did that, how come I can't get it? I've been doing this for 20 years. Its secret was in what they did. They dipped them twice, 1, and 2, they were in a high humidified room. That means you have lots of moisture. For cold patinas, Florida's the best. Hawaii's really good. Okay, Arizona, the worst. It's so dry in Arizona, you don't have any water in the atmosphere, and patinas need water to bloom. Cold patinas, not hot. Okay, so this is great. Rainy day, perfect. You're getting all this moisture. And so it causes the patina to bloom, what we call blooming. Okay, so we'll do we have a piece of cardboard so I can block this off, and I'll do half and half. I'll show you the difference. Now, this one you're going to see in about 15 minutes. but it won't reach its full color unless you want to seal it, but you can't seal it till it's dry, for about 24 hours. So what you see in the first 30 minutes is not what you're going to see overnight. It's going to little change some. Every coal patina that's an acid needs humidity. Now that's great in the patina, but it's terrible when you're trying to seal it. Because if you seal in moisture, you're in big trouble. You get all these clouds forming underneath your seal coat. Okay. So we'll watch this mature, bloom. If you have any questions, ask them. There is no stupid questions, only stupid answers, okay? No stupid questions. That's one thing I learned as I got old. I didn't care if I asked a dumb question or not. I wanted to know, you know, and you sit there and you don't ask when you go, I don't know what he's talking about. So ask questions. That's what we're here for. Okay, so this is light green on one side. This is my strongest green. I have a lot of greens, or we have a lot of greens, but this is the strongest one. So we'll put it on liver. I'm putting it on what's my right side. You're going to see a big difference between the livered one and the one straight. Now, if I'd have polished this or made it a little bit shinier, which I could do with a wire brush on a side angle dry grinder. You guys all know what a dry grinder is? You probably should at this point. That is fine. It still gives you a little bit of tooth. Okay, you can see the green. Bronze takes a little longer than copper. Brass is the slowest to develop because it has zinc in it. Okay, it's got 40% zinc. Zinc doesn't patina that well. So you can just start to see a little bit going on here. This will take a little bit longer on this side because of the liver. Don't worry about the cloudiness, that's okay. Now I'm going to put the Tiffany Green, which is going to take a while. Now spray. Spray is one way you can do patinas. We're going to use a sponge. Sponge is another way. Brushes are another way. They're not as important in cold patinas as hot. Hot, whether you have a brush or a sponge or you're spraying it on in a mist or you're doing droplets or you're doing a stream. When you look at my book, you'll see some of the ones look like a marble. I've got veining going through them and all that. That's our hot patinas. To do that, I need to control it, so I need the hot. So when I put it down, it instantly does something. Okay. Everything so far is cold. We haven't done anything that's hot yet. That's good. Good point. See, I mean, I didn't say that, and you don't know unless you ask. You know, there's a lot of information in this old mind of mine, and the guy had a neat article once. He said, "Why old people can't remember things is they got so much in there they got to find it." Okay, when you're young, you don't have as much to find. You know, you can go right to it. When you get old, you kind of have to go through the files. What is this? Like I can come up with things. It takes me sometimes 10, 15 minutes, and I'll go, "Oh, okay, yeah, I remember." So this is starting to form. It'll take a few minutes. Both of these will take a few minutes to form. Okay, let's do another one. We're going to use these samples since I have them. Okay, let's say now some of the patina came off here. That's sometimes happens. Okay, depends on how clean your metal is. Cleaner the metal, less chance you have of something coming off. Okay, so the next one is probably one of my favorites, these two here. So, next, those are straight acid patinas forming an oxide. Okay, you got that. What I've done on these two is I've got acid, but I've also put oxides into them already that have been developed. So you instantly get color. Okay, this one is, in fact, there's a guy named Bruce Beasley. I'm going to go over to his studio tomorrow. He's got problems with some bronzes, and I'm going to tell him instead of using cupric nitrate, which we'll talk about later, I'd have him use this. I've used this on buildings, you know, copper buildings, and this will last outdoors 10, 15 years, no problem. It's the most reliable green I have. There's a thing called bronze disease. It's not really a disease. What happens is you have a bronze, you put liver on, let's say base, rubbed it all back, then you put on cupric nitrate, and it turns it a green. You do this hot, okay, and then you seal it. A lot of times it's aquatic things, you know, things that would be dealing with fish and porpoises, you know, kelp. What happens over a very short period of time, because of the alloy of the metal, so all of the bronzes are an alloy of something. Well, the one you guys are using is silicon bronze. It's the newest one. It's the most resistant, it's the strongest, it welds the best, and it pours the best. That's why you guys are using it. It has some disadvantages. One is it doesn't patina as well as some of the other alloys, okay? But that's what you're using. So anyway, on silicon bronze, what you're using, over a period of about a year, you'll get these beautiful blood red spots forming on the green, which I think are gorgeous, but most people don't want them. They want their kelp to look like kelp. They don't want it to look red, like it's got blood on it. So this is to take that place, but let me show you. This would probably, normally I put this in with light green and Tiffany too. This works great. You can mix patinas. Okay, let me say that now, which I haven't shown you. I've only singularly said things. But you can mix patinas. So this is this one. Takes a little while for it to work, but this is the color you're going to have. Absolutely. Positively. No changes. That is the color. Okay, now this is the other one. Again, this is acids mixed with oxides or carbonates. This happens to be a carbonate in there, copper carbonate. This has copper carbonate, as well as one that's called green chromate, which they used to use on the bridges here. Okay, that was what they call a primer. Okay, I've got it in here, so not only are you getting a great patina, and the minute you put pigment, oxides, carbonates in an acid patina, you stabilize the acid. So it helps a lot. Okay, so we'll do on half of this, we'll do this. This, again, is what you see is what you get. Usually I dilute these 50% because they tend to clog because of the pigment, which this one is doing. Can you pour? Oh, no wonder it's doing it. I miss teaching. I love teaching. Doesn't get any better in teaching art. I mean, what can be better in teaching art, you know? Okay, so here's the other one. Okay, now you can mix those. Generally, I'll mix the two. They're nice mixed. Also, I work these two both into light green. Works great with light green. Okay, so you can have really a model surface. So I could warm this up with a heat gun, which if I can get an extension cord to it, I'll do that. And we'll dry these out. These are very stable, consistent, no problems. Light green, if I was to heat it up, or Tiffany green, it's going to flake. It's going to flake off. Now, another thing while I'm thinking about that. What causes flaking? Because people are always saying, well, my bronze, my patina, my green patina, my light green, or my Tiffany, well, it's flaking off. Well, yeah. What happens is, there's a couple things, but one of them is, so you've got your clean metal, you put your patina on, you're forming an oxide, and then they go, it's not working. So they shoot more patina on. What you're doing is you're undermining your base patina. You're undermining your base patina. Do not do that. Let the thing develop. You know, everybody wants it in 3 or 4 minutes, you know, well, it doesn't happen that way. So you don't want to put another layer on. At least let that one develop completely if you're going to shoot it. Okay, make sense? Okay, you're going to undermine what it's starting to do. It's starting to lock into the metal, and then you put another acid liquid on there, and it goes underneath it, and later on you get flaking. And flaking can also be caused by your metal isn't clean. Another possibility. Okay. this one I can heat up because this works both ways. This to green, hot, cold, whatever you want to do to it. Any questions? Come on, you guys must have something. You can't have gotten all of that. I wouldn't. Another thing you can do is this. I use sponges a lot. These are sea sponges, but you can use natural sponges. You can get by those at the drugstore. You know, they're for in the shower when you're washing your body. They work great too. But the sea sponge is probably a little better. Let's take off this. Okay, so this is going to have a more mottled look. It's going to have blacks underneath the greens. Okay, so I've taken it off. Here I have it. Okay, now let's heat it up. Warm it up. Basically, for the kind of cold stuff with heat, you're going to go This is a nice, gentle way of doing patinas. If you've got copper, brass, or bronze sheet, and you're going to put a hot patina on, you're better do it with a heat gun than with a torch. The reason for that is it's so easy to burn up your patina. So when you're doing it this way, it's much more gentle. Okay? Takes longer. Obviously, heat does it in 10 seconds, where a heat gun's going to take a little more time. Pardon? It's already started bonding. And a patina takes 2 weeks to bond cold. So even though you sealed it with lacquer or wax, I don't care what it is, it's still bonding. If you wait for a month and you sandblasted a cold patina as opposed to a hot patina, you would think it was the same. It would be just as strong as the hot patina. This will actually start to open up the pores. They can use, a hairdryer is the most gentle way to do it. This is a little more severe, I mean a hot herb, but it's now I could put another patina over this, an oxide would be fine. Anything with an oxide in it would work fine. Remember, this was black underneath. Oh, these are starting to develop. I'll show them to you in a second. So that gives you an idea. This just gives you an idea, okay? I just did the bottom. Again, it's a model surface. It isn't as controlled as a hot patina, okay? That's the difference between cold and hot. Now, there's other things I could do to this. One would be to wrap cloth around it, and then I would get a cloth texture on the patina. While it's still wet, you wrap the cloth around it. One. Two, you take bubble wrap, pop the bubbles. It's in the book there. You'll see it if you go through the book, and you'll get these kind of like circles, okay? And you can use different dimensions of bubble wrap. You know, little ones, big ones, put one on, put another one on while it's wet, okay? And so that'll help. There's going to be a slight change in this one where I've sponged, because now the acid patina that's underneath is a patina. It's going to come up a little bit on this, so you'll have a little more richness in about 2 or 3 hours. So bubble wrap works good. Another thing that works good is saran wrap. So you can take saran wrap, put on your patina, wrap it with a saran wrap, move the saran wrap. You can actually draw with saran wrap. While the patina is wet, you can move it around. I did a mural 10 foot by 10 foot in these people's homes, and it had a fireplace in the middle with a copper sheet going all the way around it. And they wanted it to look like the marsh out in front of their house. So it had water, and then you have the reeds and the sky. And so with saran wrap, big giant pieces, I made a mural, and it looked like the marsh out in the back of their house. But you have to play with it. It takes a little bit of time to learn how to do it. Okay, so this is, the bottom there. Actually, the formula, which I shouldn't be telling you because I'll have to shoot you all now, is Tiffany Green with pigment in it. So you could take Tiffany Green or light green, go over to the paint store, go to your bookstore here, get really good fine ground pigment and put it in there if you want it. Maybe you want orange or yellow or green, which we have. We have every color you could possibly want. But they have to be really good ground pigment, not the coarse. Coarse you'd find at a place that sells concrete block and all that. They have a coarse pigment, but you know, that's $3 a pound for that stuff. It's good. It's very opaque if you put it in anything. But what you might want would be the really finely ground pigment, and that takes about 3 weeks in a ball mill. Okay, and it's really, really fine, and it's expensive. Okay, you know, little jar, depending on which one you get. Let's say a blue, let's say a Prussian blue, might be $30, but you don't need a lot of it in your acid patina, just enough to tint it. Okay, so now you can see these. They're working, but Tiffany green on this side, light green on this side. Okay. Same thing here. Now remember, if you look at this, you'll notice, I'll put them over there so you can look at it. This has a little bit different range of colors in it because it was this bare metal. This had the liver on it. No, this had the liver, I'm sorry. This had the liver, so it's a little bit different, a little darker than this one. You'll see that the one without a base patina is lighter. See how much darker that one is than that one? That's because I have a liver base on it. Okay, that's important, you know, for what you want to do. You know, maybe you want that light pea green, but maybe you want some darks in there along with it. So that's the difference. Let's look at one more acid patina. This is blue. So this will give you a blue patina. We have two blues. We have original blue, which is indoors. What makes blues is some form of ammonia. Ammonia like you buy over at the grocery store. That would give you, if you put it on your bronze blue, okay? So you can actually go buy your own, and same thing with vinegar. Vinegar will give you greens, and salt will give you green. So all three of those are kind of like a patina. But this is our indoor blue. Okay, so what happens with ammonia, if you put it outdoors, it sucks all of the blue out, the sun does, from the UVs. So you can't use this one outdoors. So we have an outdoor blue. And what does an outdoor have that the indoor doesn't? Pigment, blue pigment. Okay, pigment's basically inert. It's an oxide or a carbonate. So it just lays on there. But we'll do this one. Yeah, maybe I'll do it on this. This is nice. So I'm going to burnish this back a little bit with steel wool. So I use 4/0 steel wool a lot. Remember I said you're supposed to be wearing a mask, but obviously we're not.
So you can combine the greens and the blues?
Yeah. Well, we're going to actually go blues and dark. So I pulled off some of the, exposed the high points of the bronze. So we'll put some blue on. Blue is faster than the Tiffany, slower than the light green. Light green would be the fastest thing we have to So remember, if you have a dark, we're going to have a darker blue because I got a black background, just like those over there. You can see the one that doesn't have liver and the one that does, they're a different color. This is a cold patina. So the only thing so far I've shown you that really is for hot is the Vista green and the mint green. They both go hot or cold. So this will take a few minutes to work. So we'll let it sit here and we'll go on. Okay, so on this one somebody asked me if we could bring up other things. So I put a little bit of our dioxide red on there, so it has kind of red veins going on with the greens, the mint green and the Vista green underneath. Okay, now when I lacquer this, because the thing about cold patinas are they're kind of fragile. Hot patinas aren't fragile. That's another reason foundries use hot patinas, is because they're less fragile, okay, and they work instantly. So you get instant gratification, and you also get all kinds of textures that is somewhat more difficult in cold, okay? So let's go on. Oh yeah, so we need to seal all of your cold patinas at some point. We'll do that in a little while. We'll go on here. Okay, so here's one that works both hot and cold. Somebody was asking if we have a rust. We do, but I'm going to put it on warm, so it looks like a rusted piece of steel. okay? Has oranges, browns, tans, and a little bit of yellow. So this is our ferric nitrate, ferric chloride. Hot or cold? If you use it hot, it goes instantly to rust looking. Oranges, reds, yellows, browns, okay? It's opaque. It's an opaque patina. Same way if I put it on cold, it's going to be an opaque. Let me get some gloves. Okay, so we're going to warm this up a little. You guys have a nice facility here. One of the things you're going to have to do, I think, as a sculptor, is you're going to have to take computer classes, mainly because they have three-dimensional printers now, which do anything, and also because you need it to do a lot of times your work on. When I work for Industrial Light and Magic making movies. In the early 80s, I did Return of the Jedi's, Poltergeist, E.T., Wrath of Khan, and Dragon Slayer. And I did creatures, and actually they brought me in as a mold maker, master mold maker. But they found out I was a sculptor, and so I got to work on a lot of things. What I'm going to tell you has nothing to do with that. When we were doing Wrath of Khan, it's called the Genesis effect. So it made a dead planet into a live planet. I don't know if you can see that. That was the first time anybody I know of had used a computer. All the stuff we did was handmade. We had craftsmen, all these artists that were craftsmen, and so we made everything from scratch. It took months to make these things that you can do on a computer now. But, so I had a lot of friends there, so I had two of them come down to Long Beach, talk to my sculpture class, and what they did in the beginning is they let go all of the artists to work on computers and bring in computer people. What they found is they were better off to teach an artist how to use the computers and do computer graphics. So that's a good thing for you guys. So you really want to get involved if you think of this as your, not a hobby, but something you're going to want to make a living at, Mold making's a good one. Welding's a good one. And also computer design, three-dimensional modeling, things like that will all help you out. It develops much, much slower on coal bronze, or to get an instant rust look, you have to have it at 220 degrees. But you'll see a difference in a second. You'll see a kind of a soft brown. This is one of my favorite patinas. I use this all the time. It works good also on our metal coating, but what it really works good on is cheap latex paint. So if you put latex paint on a sculpture, and then you shoot this on it, maybe put some plastic wrap around it, you can get just the most incredible colors, rust browns. But we're getting something. I mean, it's coming. I just wanted to, we've gotten blues, we've got greens, we've got a kind of a soft brown, we've got a black, so you're kind of getting some basic colors. The whole thing is practice. You don't want to do your piece until you practice on something else. Don't start on well, you can sandblast, that's not true, but you're better off if you play around a little bit. I spilled some liver on this one a little bit, so we're getting different kind of colors coming up. But see, if I had done this hot, it would have been finished at this point. I think you guys are waiting for a hood, you know, a ventilation hood. But I can show you a little bit. You'll see a little. You'd have to work on it for a good 5 minutes doing this to really bring up a lot of color. If you left it overnight, it'll do it by itself. But you can kind of see color. Now let's say I decided I want to bring some white into it. So this is our dioxide white. This is not an acid, non-acid, okay? Works great over patinas. It can work by itself, but it works great over patinas. So I'm going to take a sponge and I'm going to do a little bit of veining. So this is basically titanium oxide. Same thing they use in paint to make white paint. We'll pass this around in a minute. Okay, so we're starting to get some nice colors. I'm going to bring in a little other color here. So dioxides, generally they go real nice over patinas. You can use them by themselves. You can put them over a patina. They're a little on the fragile side, so. Pardon? When you don't have an acid to form crystallization, it basically is. So we'll do it on this piece right here. So this is called layering. Okay. So you can see the different colors going on here. So this is layering. So if you noticed, I took the spray bottle and I put droplets on there, so you've got kind of a pebbly look, okay? As opposed to a stream, which would give you a vein, as opposed to fine mist, which is going to give you a real even patina. I wanted a more mottled surface. I could also bring in a little green. Now these are, I'm going to show you these only because these are our universals, little different than the dioxide. Dioxide's transparent. Universals are opaque, but they have a binder in them, so they really bond to the metal, particularly if you put them on cold. And you can use all these things together. You know, you can do anything you want together. You know, layer. These are all layering now. What is that? This is our verde, which is a light green. So this is going to instantly give you some color. I'm going to hit this a little bit more with ferric. I'm just trying to give you some ideas. When you put an acid over it, it kind of subtles out the color. I'm going to put a little bit more pebbly in this. Now you could also expose this kind of a textured form. So here's a bunch of different, I've showed you different looks, but you can kind of get an idea, okay? Now, so we've got acid patinas. We've got acid patinas with oxides in them, vistas. We've got straight acid patinas. We got base patinas. I know this a lot. Then we talked about dioxides, which are transparent. Then we talked about the universal. Those are our groups. And they're non-acid, but they have a strong binder in them. The same binder you use for bonding kiln bricks. They'll take 2,500 degrees. Okay, and they make a strong bond, but they're opaque. So you got dioxide, transparent, and all of the rest of them basically are opaque. So this isn't ready to put a seal coat on yet. It's dry, but it probably needs more time to evaporate the water, wick the water out, okay? In this one you can see the greens and the blues forming.
That's pretty. That really is pretty.
So we'll put this here. If I warm this up, then I can do the same thing to this I can to that one. So let me warm this. We'll pull out the water. What we're trying to do is pull out the water. Water is great when you're trying to make a patina, but when you're trying to put a protective coating, it's your enemy. You don't want any water in there. Are all of you freshmen, sophomores? Raise your hand if you're a freshman. Sophomores? Any juniors or seniors? Yeah, oh, okay. She was asking about an oil spot. The best thing for cleaning that little area is we have a graffiti remover. We have a graffiti coating that you can put on buildings, and then if you put graffiti on, you can take our graffiti coating and wipe them right off. Okay, it also works if you've got a little bad spot somewhere on your bronze, brass, copper, iron, steel, makes no difference. You can take the graffiti remover and rub that area and it'll clean it, and you don't even need to wash it. You can put the patina right over it. Remover. And Douglas and Sturgeon's sells most of this. You have one, a store here in the city, and you also have one over in, where is the, Richmond. The thing about sculpture supply places, there's only about 6 or 7 of them in the United States. You're lucky you have one here. There isn't that many places that sell sculpture products or mold making or anything like that. This afternoon we're going to not only do some clay, but we'll do plaster. My metal coating works on anything, and it's good for 20 years outdoors. So our metal coating is really good. What a lot of people I know have used it on is gutters, steel gutters, make them look like copper. Save about, my friend was going to do his house, it was $16,000 for the copper. We did steel galvanized with a primer and my metal coating and made it look like patinaed copper, aged green. Costs about $1,800. Okay, now, if you put on a lacquer, so we have 2 kinds of basic lacquer. We have our EF, which is environmentally friendly lacquer. That means the VOC is very low, meets OSHA standards. And then we have a regular lacquer. They're both the same strength. They're just, depends. If you're a green person or in a green area, you might want to use this one. Also, it's less toxic. Less VOCs, the less toxic it's going to be. This is a matte. This is a satin. We have satin and matte. And we're leaving all this stuff for you guys so you can try it out. So this is what you'd want to seal. This is your metal surface. You got your patina here. Bronze, and then you've got your patina here. What you want to do with your lacquer, either the EF or the regular or whatever you buy at Home Depot, what's nice about all our products is we have all of the UV inhibitors in them. Rust inhibitor, chemical inhibitors. We've got all the inhibitors you need if you're going to go out into the environment. You know, which ours is one of the very few that have all that, you know. So now you've got this, which is your patina. What you want to do when you spray on your lacquer is make sure that the lacquer goes through the patina and bonds to the metal. It's very important, okay? Because cold patinas are fragile. I'm not talking about hot patinas now, just cold patinas. So you want the lacquer to bond the patina to the metal and give them the patina time to bond to the metal, which takes about 2 to 3 weeks. So now if you put on, obviously, lacquer when the metal is hot, it's not going to penetrate. So I don't care at this point. All I'm trying to do is show you something. But normally you wouldn't do it where the bronze is hot unless it's a hot patina, and then you could do it. And no matter whether it's satin or matte, when you have the metal hot, it's going to give you a matte look, okay, as opposed to a semi-glossy look. So I'm going to do kind of a half deal here. So I'm going to put half of the clear lacquer on. You'd really, okay, so that's on there now. Okay, now, let's say you're not happy with that look. You want a little more golden brown, okay? So we have our clear guard with a solvent dye we sell. And so we've mixed the two together. Now you've got a slight tint to your lacquer. So this is going to tint your patina. It's going to seal it, everything, and it's going to tint it. Yeah, that's why you want it won't hurt you because these are all, it may smell, but it's not. So this is yellow, and I'm going to put a little brown over that.
So is that just like a pigment spray type?
It's an oxide and a dye that is in the lacquer. So you can kind of see the difference now. So a lot of conservation, restoration friends of mine use these on outdoor bronzes. It's an easy way to get a patina. You just kind of put a base patina, liver, then you take these, put it on, and you can have a golden brown just like a ferric nitrate. But you don't go through all that process. I mean, these are fail-safe, you know, what you see is what you get. So, and we have black, and we have all kinds of colors. On the other one, this one here, to confuse you even more, I'm going to put this on. And this is our Smart Stain. Now, where this is a solvent-based, if you don't like solvents, then you can go to this one, and it's just as good. It's water-based, so you don't get any fumes at all. There's no VOCs, no nothing. Again, we make it so that there's just a slight tint to it, okay? It doesn't completely eliminate anything. It just gives you a slight tint. Takes a little longer to dry because it's water-based. Solvent-based they wick quickly. Water-based take a little bit longer, but so that's with the red over. Okay, so this is environmentally wonderful. It's great outdoors. All of them have inhibitors and everything in them. So we'll put these over here. This one I'm going to shoot just regular, well, I'll shoot a blue. Blue will be really nice over this one. So we have blue in both the patina stains and in the smart stain. Blues are one of my favorite. I love blues. There's the blue. Okay. So we'll put these over here. You can look at them. What we're trying to do, one of the reasons that Debbie's made the company so successful is tech support. You know, one of the things you need besides our online YouTube is the fact you can call us and get help. You know, sometimes you need help. You know, it's not that simple. Some of these things are simple and some aren't. Obviously, this is simple. You just spray it on, either one of these, and it's simple, but some of the things are more complex. Now, let's go one more. Let's see what we've got here. Let me do another liver, just because it's quick. No, I think I'll do, this is ours. Every one of the base patinas, except for liver, have selenium in them. Selenium is your agent that causes things, metal, bronze, brass, copper, iron, steel, aluminum, to go dark. So selenium is your base. So depending on how much selenium and what you've got with it determines on what the color is going to be in the range of browns to blacks. So every one of these is going to be just a little bit different. The darkening is going to be a little different. The antique is going to be a little different. In the black magic, they're all just a little different. You have to try them, see one you like the best. But let me show you this. So we'll let this come up for just a minute and then I'll show you some stuff. There's not a lot that works on sterling silver. Okay, one is liver, which if you've taken jewelry, that's your standard. So ferric nitrate, ferric chloride will work if you heat up the silver. Okay, it'll give you a slight brown, different brown than liver. All of the dioxides and the universals will work on silver. All of the patina stains or the smart stains will work on silver. Okay, but you're not getting a lot of reaction. At least you're getting some reaction. If you had gold, you're not going to get anything. Gold basically retards any kind of oxidation. Okay. Okay, so we got this. Let me take down a little bit of this. So this is our darkening. Hasn't gotten to full place yet, but it's getting there. It's developing. Takes a little longer. So I burnished back the spot, left another one open. So it has kind of a grayish black, which will go to brown if you were to warm it up or if you give it some time. Okay. Okay, let me heat this up. Now, with all of them, you can heat them up after you put the brown on and neutralize it. And then you might want to burnish it back more depending on how much darker it gets. Because they all have selenium in them, so they're... Okay, so we're going to put, okay, next thing we're going to talk about is colored waxes or wax. And I know there's only a couple companies in the United States that makes waxes for metal. All the rest of them, Johnson's Paste Wax, Staples, Bowling Alley, Tree Wax, which would be my favorite if I had to pick one of those, are made for wood. Ours are made for metal. They've got all the inhibitors and stuff in them. So what I'm going to do is I'm going to put some wax on these and tint them. So that's another way of going. Okay. The difference between the lacquer and the smart stain, the protective coating that's in those will last maybe 3 or 4 or 5 years. Waxes are generally only good, we're talking outdoors. Indoors, you don't have any problems. It's always outdoors. You're probably looking at a year, maybe a year and a half. Outdoor needs maintenance. That's something people don't seem to understand, that by all these bronze and brass clad windows and doors, which are really expensive, and then they have a brown patina on them, and within a short period of time it goes green. Well, that's because the protective coating, if they have one, is broken down. And so maintenance is a real, I think a person that wanted to go into something could go into restoration and probably do pretty good.
So going in and knowing that the wax only stays, the texture will only be on for a year, are you doing that because you want them to call you back in a year?
No, we don't say that. You know, some people want wax. They want wax. Wax is the way they want to go. All you do is try and inform them that the wax isn't going to last that long because it breaks down, even with all the things we've got in it. It's going to.
You can't put lacquer on top of wax.
You can, if you only have one coat of our wax, you can put lacquer. They bond somewhat. Basically, you would like to put the lacquer on first and put the tinted wax over the top. Okay, so normally I would tell people, put your, saying that you want to put, you could put just the wax on, but, so this is one color, and we're going to put 2 colors here, and then I'm going to put brown on the other side, but, so this is wax. Okay. Outside. Inside, fine. Okay, let me put the other one on. You can do a lot with waxes. Waxes were another thing they used in the 18th, 17th century. Beeswax with pigment. Just basically what we're doing right here. But it was beeswax, and beeswax breaks down very quickly. You need a bunch of things, and ours has a binder as well as wax. So you're getting a lot of different things in ours. That's why ours doesn't break down, and we have one that's super hard. We have an outdoor super hard wax, and we have our regular wax. So it depends on what you're doing. I'm going to go see Bruce Beasley. He's an artist here in the Bay Area. He's probably I know he's the richest Bay Area artist. And if you haven't looked at his work, it's in the book there. Anyway, he wants me to come over and talk about some pieces that are in Palm Springs where it gets 120. And the wax he put on, which I gave him our wax, didn't use it, broke down. So everything went. So the whole piece went to crap. That's what happened. Okay, I'm just doing one side so I can show you, but this is what you could possibly do with wax, with a base. And I'll buff it up. It takes, okay, just to give you an example, a guy calls us and said, your wax failed. I put it on my bronze, put it outdoors, failed within 2 or 3 days. So I said, well, first you have to ask them what they did. And then you have to kind of read between the lines because they don't tell you. They say, I did exactly what you said. You have to kind of read between the lines of what's actually going on. Anyway, so he said, and I said, okay, how soon after you put the wax on did you buff it? He said about 5 or 10 minutes. He took all the wax off. Rule of thumb, on wax. You rub your finger over it and you look at it. If it looks oily on your finger, you're not ready to buff. If you run your finger over, nothing comes off on your finger, you're ready to buff. Because if you don't, you're going to buff off the wax. We'll put the brown on the other side just to show you. And we'll buff them later. I'm going to buff these later on, but they're going to be here for you. You guys can look at them later on. Wax goes, they all go a long ways. You know, you don't have to buy a lot of everything. And you're going to have all these here anyway, so you get to play around. So this is brown wax. We have brown, black, green, orange, yellow, blues, 2 greens, white, just about every color you can imagine. So this is going to be brown wax. Now it'll look 10 times better when it's buffed, by the way. It will really come out nice. We have a carnauba, we have everything you can put in a wax. The only thing you have to do with our wax is make sure you get all the streaks out if you're using a brush. It's 5 times harder than any other wax. If you let it get dry and you got streaks, you're not going to buff them out. You ain't going to have them. You're going to have the streaks in there. So now this is just liver with brown wax. So that's not a bad range for our things. Oh, let's see, what else was I going to show you? Okay, the other thing we have, and we didn't bring it, was oil. Basically, oil is really good for steel and iron. Because what happens is you, with our oils, which are tinted too, just like our waxes, is that it wicks water. So that means if you put it on something, particularly steel and iron, what you're really worried about, it wicks out the water, okay, and that's real important. So it seals and wicks at the same time. I used to put it on just a little bit warm. If you put it on warm, here's the thing. If you put it on warm, obviously you've opened the pores of the metal, and when it cools, it locks it in a little bit, depending on how hot it is. So I always try and just warm it up a little bit. Yeah, thank you.